Hey guys, I'm Anixius, and in this video I'm going to be showing you how to do really easy and simple networking in GameMaker. To do this you have to not use any drag and drop, you have to use GML, um, otherwise you don't get the ability to do these functions, and it's just way easier. So I have a really simple game here. I'll demonstrate how it works. My friend, Locomon34, is joining me today. And I don't know why he's being quiet, but he is here. Say hello.
Hello, everybody.
Ow. Alright, I'm just gonna demonstrate how the multiplayer actually works, so if you would not mind joining, just to prove that it actually does do multiplayer.
What am I joining?
Just join. It's not one of those other games. It's just a space game.
Okay. Oh, I just
Hoshina
pasted
2.
the wrong. Hoshina 2. I just pasted the wrong thing. I apologize for apologizing.
Oh. Nope, there he is. He is joined, and he can see me and himself, and he is able to control his ship. He, okay, he's just leaving. Yep, nope, he's just gone. He's never coming back.
Right now, our internet's bad because there's a storm outside. So I teleport a bit, so I can't really control myself. But the multiplayer works fine.
Yeah, so when the internet's fine, when your internet speed is okay, then things don't teleport a whole lot. But since we both have not the greatest internet, mine's really bad sometimes.
And it is storming. So
And it's storming in his house. Yeah, so it's not the best. Oh, I saw you come back right as I closed it. You literally popped in as I closed it. Alright, so I'm just going to be going over how it works. So I have three simple objects: server, a client, and a ship. I'm going to go over the ship's code real quick, really simple. I set up a little bit of some stats. So object ID, this represents the ID of the object on the server that this ship imitates. So this ship is an image of another ship on the server. So this is the ID of the object on the server that it imitates. Image speed is 1.6, so this is just 10 frames per sec. 10 frames per second instead of 60. For the fire animation, acceleration is 0.1, so speed will increase at 0.1 pixels per frame every step, every tick, every frame. Max speed is 2, so they can only go 2 pixels in a single frame, and then they clamp, they max out. Control is true. If this is false, then the keyboard does not affect the ship, only the server will affect it. These are the key inputs: key forward, key reverse, key clockwise, key counterclockwise, and key brake. These are all the controls that I currently have. Brake is not really useful. I just have it there just in case you want it. Slowdown is true. If you run out of fuel or something, slowdown would be turned to false and you would just sort of float away forever. So don't run out of fuel. Rotation speed is how many degrees you're rotating per frame. Rotation acceleration is how many degrees per frame to increase the rotation speed by every frame. Kind of confusing. Rotation max speed, so this is the max amount of degrees you can rotate in a single frame. Okay, so that's just setting up some stats. Now we got the step event, or begin step. So if you have control, then it makes these keyboard things equal to whether you're pressing a specific key or not. So true or false depending on whether you're pressing these. So this would turn true if you're pressing and holding W. Same with this and S, and this and D, and this A. Then this if you're holding left control, you break. So first we set F to 0, a local variable. It will be deleted at the end of the event. That's what var means. So F equals 0, just to mean that you're not going forward or backward, is what that means. So if you're not holding the brake, then F is now equal to forward minus reverse. So if you're holding forward and you're not holding reverse, and that's 1, because true is also 1 and false is 0. So it'd be 1 minus 0 gives you 1. So F is 1 there. And so then we add motion in the direction your ship is facing, equal to the acceleration, so how fast you go, increase your speed at, times F. So if you're forward, that's 1, anything times 1 is itself. However, if you're going backwards, this would be 0 minus 1, so it's negative 1. So then you'd be adding negative acceleration in the direction you're looking, so you go backwards, or slow down. And if you're holding both, it's 1 minus 1 is 0, and if you're holding neither, it's 0 minus 0 is 0. So this does account for holding both. Then we have if F is greater than 0, so if you're moving forward, then we set the animation to the flying animation, and we randomly choose one of the frames to set to so you don't always look the same. Otherwise, we set you to the idle animation, which has no thrusters going. And if slow down, so if you have slow down set to true, which we do right now, speed divide equals 1.05, so we divide your speed by 1.05 to slow you down a bit. And then we go to the rotation controls. So var R equals counterclockwise minus clockwise. So if you're holding the counterclockwise key, this would be 1. If you're holding the clockwise key, it'd be negative 1. If you're holding both or neither, it's 0. So rotation speed plus equals rotation acceleration. So that makes sense. Times R. So R changes the direction to add the acceleration in. That's pretty simple. If you understood how this worked, then you should understand how this worked. Slow down and R is equal to 0. So if you're not rotating at all, and slow down is true, then we reduce your rotation speed by 1.05. Divide it by 1.5. If your speed is greater than your max speed, then we set speed to max speed. So if you're ever faster than the max speed, then you're immediately clamped. Rotation speed is clamp, rotation speed, negative rotation max speed, and rotation max speed. So you can't move outside of the range of your rotation max speed, negatively or positively. Image angle plus equals rotation speed. This just changes the way your ship looks to rotate with your actual rotation. Now, I didn't actually use direction here, because direction is influenced by motion add and image angle, so I'm not messing with that. And if slow down and your speed is less than 0.1, and you're not holding a key forward or backward, then speed is 0. So basically, if you're going slow enough, it just stops you entirely, so you don't just float around. So that's how the ship works. It's just simple controls. So next we set up the server with server stuff. Now, in order to do networking, you have to use something called buffers, and you can think of buffers as kind of like a mail, like an envelope. Like they can hold, or maybe you can do like a package or something. You can put things in the package, and you can take things out of the package. So they're kind of like a little box or something, and you can mail them to other mailboxes and stuff. That's kind of how networking works. So first, you define a size, and I think that's in bytes, and not kilobytes or anything, so I think it's in bytes. So I've set mine to 1 kilobyte. You can set it to whatever you need. Then you set a type for the buffer. In this case, I chose buffer grow, so whenever the data exceeds the size of the buffer, it makes the buffer bigger so it can actually hold the data. So, yep. Then you have alignment 1. You don't really need to worry about alignment unless you have very specific needs for this buffer. However, in networking, you pretty much just need to set it to 1 and never worry about it again. Then you have port. This is the port that I will start the server on, and that other players will have to connect to this port to actually be able to connect. So this is the listening port. Then we have a password. So whenever players join, it requires a password to allow them to actually join. I have that disabled. I haven't coded that in yet, but I do have the foundations for it ready to go. Max player is 4, so if there's ever 4 players, it will not connect anyone anymore until someone leaves. Server ID is a unique string of characters, which randomly generates right here. I'll show you how that works. Type is a UDP socket. UDP and TCP are the two types of sockets you should generally deal with. TCP is reliable and sends things in order, and if something doesn't send, it will send it again and again and again until it actually sends, and it makes sure that everything arrives in the right order that it was sent in. UDP does not care. It will drop stuff and it won't tell you. So if a message drops and no one gets it, that doesn't matter to UDP. And things can arrive in the wrong order. So there's some things you can do about ordering, but generally it's fine. This code randomize just randomly sets the random seeds, so random numbers and stuff don't always become the same thing every time you play. So now we have server ID plus equals char, and then all of this random nonsense. So what this does is it chooses one of these two iRandom ranges. So it just chooses one of these iRandom ranges, and the iRandom range picks a random number between this, and it can't pick decimals. It's iRandom. I means integer. So if I just had random, that would allow decimals, and it would actually choose every single number possible. It can choose anything. So iRandom just chooses 48, 49, 50. Now what these numbers mean is these are actually letters, I believe. No, these are the digits, like numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are capital letters, and these are the Unicode number that represents these characters. CHR just converts a number to a character, so if it chose 48, it would return 48. CHR 48 is the 0 character, while if it chose 65, it would return a capital A. So this just generates a random string of capital letters and digits. Start equals false. This will say if start is ever true, it will try and start a server, unless it's already started. Started equals false, so if the server is started, that will be set to true. Server is -1, there is no server yet. Tick is 0. Tick increments every frame to limit what is sent. Now we have an enumeration, and enumeration is just a name for different values. So like command dot null in this case would return a -1, while command dot connect would return a 0 because 0 comes after -1, and then command dot input would return a 1 because 1 comes after 0, and so on. I didn't have to put that equal sign -1. I just wanted null to equal -1. So whenever I send messages through the network, I have to head it with a command so it knows how to process the data I send. Then I have a data list, so for every client or every player that joins, the lists here will be populated with data, and all of them will, so that the same position in all the lists corresponds to the same player. Okay. Next, in the step event, we actually start the server. So if start is true, and you haven't started yet, then start is false. So immediately set that back to false, so this doesn't run anymore until you set start back to true. Then we set server to equal network create server, which will create a server of the type, in this case is UDP, a port, so the port that we defined earlier, and max players that we defined earlier. Then we check if it successfully created the server, so it would return a number 0 or higher, then started is true. Otherwise, then started is still false, and the server is not open. We also increment tick. Tick plus plus just means tick. Add 1 to tick. Okay. Sync player ships. So here's the complicated bit. So first we say if the server is started, and then we say if tick mod round 60 divided by 10 equals 0. So what this whole thing means is only do it if tick is divisible by 10. If tick round 60 divided by 10 just means 60 divided by 10 is 6, rounded is 6. Sorry about that. Means tick, whatever that is equal to, divided by 6 if the remainder of that is 0, then that means like 6 divided by 6 is 1, where the fraction is 0, so it has no remainder. So if tick is divisible by 6, that only happens 10 times per second. So we're limiting it to sync player ships 10 times per second instead of every frame, because that would eat your bandwidth. So first we make sure... Oh, that's an issue. Whoops. So first, we make sure that there's more than no clients in the game. We make sure there's at least one player. You can use any of those lists here. It doesn't matter, because all of them will have the same amount of data in them. Like I said, every time one gets a new input, all of them have to get an input to the same position, and one corresponds to the same player in the others. So then we loop through all the players in the game. And a for loop is just what I said. It loops through all the code. So in this case, it loops through everything between these highlighted brackets. So first we set var I to 0. So var, so that I is destroyed at the end of the code because we don't need it. And we set it to 0, so it'll run all of this as where I is 0. So you see these i's here will be replaced with zeros. It says as long as I is less than the size, but basically as long as I is less than the number of players that are in the game right now, then increment I by 1 every time we reach the end of the loop. So I starts at 0, and as long as I is less than the number of players, we keep doing this code. So I is the position that is receiving this data, receiving the player sync. So first we set keep going to true, because by default we want to actually send all this stuff. But then we say as long as the client object is ID is not the same as the ID we're sending to receiving, then you can keep going. But if it is the same guy, then don't go, because you don't want to send data to the host of the game, because he's the host. He already knows what's going on. His game is the game we're syncing. We don't need to sync things to the host who's already playing as the server. So we kind of ignore all of this for the host. If you keep going, if it's not the host that we're talking about, then we loop through all the players again. In this case, we use J because we already used I up here, and we're still in this loop. So for each loop through this, we loop through all the players again, except this time we don't filter out the client, because now we're sending data about the client to everyone but the client, or but the host. We're sending data about everyone to everyone else except the host. We're sending data about the host, but not to the host. So we loop through all of them again. We set O to the client object that represents the guy J, which is what we're sending about. If that O exists, so if there is a ship that that corresponds to that guy, that represents that guy, then we send info to the everyone, to everyone else. So first we seek the buffer. So basically we move the writing point of the buffer to the beginning of the buffer. So we are writing from the beginning. We specify which buffer to write to. So in this case we have buff. Then we say buffer seek start. It's like the base, okay? It's like where we're seeking to. So we're seeking to the beginning. And then offset. So we're not going to offset off the start, because we want to write right at the beginning. We don't want to right at the beginning, but then a little bit ahead of the beginning. So 0, because we're writing at the beginning. So then you buffer write, buff. So we're writing to the buffer. Then you give it a type of data we're getting. So this is a buffer string. So we're writing a string right now, which is a text. So we're saying server ID. So first we're going to put the server's ID in the little buffer, the package. Then we write an unsigned 16-bit integer. Unsigned means it can't be negative. It can only be 0 or higher. And 16-bit is just how big the number can get. So the higher that bit size, the higher the number can be. Generally, you don't have to make this very big for a lot of things, but yeah, don't use more than you need, and you'll be fine. So this is the command that we're actually sending. So this is command.input, so we're sending an input command. Which I should have probably made up a new one, but I didn't really feel like I just reused it because the server is never sending input to the client, so I just used that. Then we send the ID of the object on the server, like I said before, using an unsigned 32-bit integer, which is much bigger than this. Then we do a floating 64-bit number. Floating means it can have decimals. Integers don't have decimals. Floatings do. Floating also includes negative numbers automatically, so you don't have to specify if you mean unsigned or signed. It's fine either way. 64-bit is really, really big, so these should be fine until your ship gets really far away from 00, which we've done before in a game. We got really, like, billions and billions of pixels away from the center of the universe in a game like this. I'm currently remaking a game. So then we do the same for Y. Then we use a 32-bit because F16 is not supported. Like, it's there, but it doesn't work. It says it's not supported yet, so I always use 32 when I don't need a number as big as 64-bit. So this is the image angle, that basically the direction the ship is facing, like looking at. Then we speed, how fast it's going, then the direction it's actually moving in, not the direction it's facing, but the direction it's moving in. Because you can walk to the right. You're not facing to the right, but you're walking. Your direction is right, but you're facing forward. Then we do the sprite index. This is another unsigned integer. Sprite index is just the asset, the name of the number that represents the sprite that is currently being used. So this case, I don't have to sync anything about animation. I just let the clients animate it automatically. And then a bool is true or false. It stands for boolean. It's just a 1 or 0, 1 being true and 0 being false. In this case, I did I equal j. So if I, the person who is receiving data, is the same as the person j who we're sending about, then that's true. Otherwise, it's false. If it's true, that means that the ship, like the client who receives this ship, knows that this ship represents them and they can control it. So basically, if this is true, they can control it, this ship that we're talking about. Otherwise, they can't. So if client is this ship, yeah, I even made a little note there. Then we network send UDP. We actually send the package to that person. So we specify a socket to send it through, so that's the server. Then we get the client's IP that we saved in the I, because I is who is receiving. Then we do the client port at I. Buff is what we're sending. You can see these down here. And buffer tell just says what the size of the buffer actually is. Oh, jeez. Yeah, and then you have this else continue, so if it is the host, then we just ignore this I. So that's syncing player ships. And now we have the network event, really, really simple. If async load ID. So whenever you receive data in GameMaker, it triggers a networking asynchronous event. And this code right here will make sure that it was intended for this object, because this object can see if it's received data even if it wasn't intended for the server. So like if the client receives data, let's use a better example. Let's say someone sends their keyboard input to the server, but the client thinks it was for him, so he reads it, and you crash because it wasn't the right data. So in this case, we just check if the ID, if the socket we're sending to is supposed to be the server, then we call the server data script. And I'll go over the server data script in a sec. Now we have backspace. Just if you say if the server hasn't already been started, then start to true, so that it can try and start the server. So now we go to server data to look at how this works, and client data is extremely similar. So first we set a BF to represent the buffer that it's loaded. So this is BF is now the buffer that was sent to the server. RIP is remote IP, basically the IP of the sender. So basically where this the IP of where this buffer came from. Did it again for port. Then I seek to the beginning of buff or BF, so so we don't have any errors in reading, like reading outside of the buffer, even though we know there's enough data there, because that's a problem. If you try and read more than that was written to it, then it will have an issue. Alright, then we have ID, the received ID, so that's the first thing we read, because every message sent to and from the server has an ID first, and it's always a string. Then it has a command, which is always a U16, so it reads those. Then it has POS, and POS, it tries to take the index of the ID that is received from in the client ID DS list. So it tries to find the index. Ooh, it's raining here now. Tries to find the position in the client ID list where this RID is. Which, if it doesn't exist, it will return -1 or some negative number. I think it's just -1. But if this is 0 or higher, then you know that client has already connected, so it's a connected player. So then we switch, which basically we pass this, and we have different cases for what this value holds. So if CMD is equal to command.connect, then we run all of this, and then break ends it in this case. Then we go to the next case. If it's not command.connect, then if it is command.input, then we do this. So if it's command.connect, we first check if POS is negative. If it is, that means they haven't joined before. So that means that they are not connected and they have never been connected. So first we add them to the thing. So we add their data to each list. Then we create a ship to represent that person at 9696. Then we default to make them lose control. Then we check and make sure that this person who just connected is not the host, because the host has connected to himself. If it is the host, then we don't make him lose control of the ship, and we keep giving him control so you can actually move your own ship around as the host. Then otherwise we set it to not have control locally, so that the host does not control all ships at once, which I had a problem with. Then we add that ship to the object list, just like we did with these. We add another thing. Then you have to tell the client that they're connected, because otherwise they'll never know that they connected, and they would just start suddenly receiving a bunch of data, and they'll start ignoring all of it. And they'll be connected server side, but not client side. So first you seek to the beginning of the buffer. You already know what that means. Then you write the server's ID. Like I said, as always, the first thing is read is ID and then the command. So you give it ID, the command of connect. And then I added another thing I didn't really have to, which is a bool. I just said true. That means yes, you are allowed to connect. I'll also add a false, and then after that, after the false, I'll sync a string, and you can then the server can tell the client why they did not connect. And it could be like bad password, or server was full, etc. So you can send like why you didn't connect from the server. So then repeat 3. This just ensures that they actually get the message, because if they don't get this message, that's really bad. So they really need this message. So we send the whole, we send all this 3 times to ensure that they get the connection that they need. So then we send it to where we got it from, and we send the buff. Okay, now if the command was not connect and it was instead input, then we check and make sure they have already connected to the game. And if they have, then we set O to equal the object or the ship that represents that player. If it exists, then we set its input buttons equal to what the client has sent us. And that's about it for the server. Now we go to the client and we learn more about the client. So the client is pretty much the same, except it has a couple extra things like connect IP and connect port. So this is where it's going to connect to. Port in this case just represents the port, the listening port for the client. It has to be different than the server because the host has both the server and the client. They can't both be on the same port. So I randomize and I give this guy a client ID. Later I will save this to a file, so if the server has saving. When the server saves data, it'll save the client ID, and the client ID will only randomize once you first open the game, or if you lose data and have to open it again. Then that way, like let's say in a game, which I have done this, you have pets. The server would sell the pets the ID of the client that owns them. So when that client disconnects and reconnects, the pets still belong to that guy. So that's pretty useful to have. That's really only reason why I have client ID is because I could get by with just having the POS, the index in the lists represent different guys, but this is very useful, and it also really helps with determining whether someone is the host or if it's just a non-host player. So we have connect equals false, so if this is true, then it would attempt to connect at the given connect IP and connect port. Connected is false by default, so the default you're obviously not connected as soon as you play the game. And then we create a socket, and I should actually have changed this. I'm surprised it didn't break. Weird. So, yeah, I just advanced this a little bit so that it creates an extended version of a socket. Basically, it makes a socket on a specific port. I don't know why that was actually working. That was kind of weird. So then we have another tick for this so we can limit input a little bit. So then we have connect to a server. If connect, so if it's trying to connect and not connected, so if it hasn't already connected, connect equals false, so it doesn't try to connect again, and it will send a connection request. It basically seeks, writes his client ID, and writes the command connect, and then it sends it. It doesn't give any other data, just those two required data types. Then we add one to tick, and then we send the keyboard input, basically the keys that are being pressed. So first we check that you're connected, and tick is divisible by 3. If tick is divisible by 3, that just means every 3 frames we want to send this. So it basically makes it so you're not sending data every frame, and it helps with bandwidth, and yeah, that way you can actually run the game and it doesn't kill your internet. First we seek to the beginning, we write the client ID, we write the command input, then we write keyboard check or W. This basically just means if you're pressing W, this is true, otherwise it's false. And we're sending if you're pressing W. We're sending if you're pressing A, pressing S, D, and if you're pressing left control. Then we send it to connect IP, connect port, and that's it. That's all we do. Networking event, exact same as the server. It just checks if the ID and async load is equal to the socket, or on the server's case, it's server. And then we call client data, which I'll show you in a sec. C just sets not connected true if you're not already connected, and I will ask for an IP. So if you're not already connected and you press I, first we'll set a temporary local variable str for string to get string. It just says IP, like asking for the IP, and the default value is the current connect IP. So when you first press that, it'll be the default IP, which is 127.0.0.1, which means localhost, so connecting to this own computer. Then it says if you didn't enter nothing, or like if you hit cancel, it also enters nothing. So as long as you didn't hit cancel or you did input something, then we update connect IP to the new string, regardless of whether it's valid or not, as long as it's not empty. Now client data, last thing we have to go over is this script, which is not that much different from the server data. BF is the buffer. We seek it. We have a couple less things. We don't need RIP and RPort because we already know the IP and port because it's the server. On the server side, it has many clients to deal with, and the client side, it only has one server to deal with, so it's much simpler. So we just need RID, remote ID, so we just need the ID from the server, and then we get the command that we need. If it's a connect, then if we're not connected, we set connected to the thing that it sent, which by default right now is always true, so it automatically connects. Then we do input. If it's an input, then we check first if we're connected. If we're not, then I don't know how we're getting this message, but if we are, then we set O to no one. Object ID on the server is the first thing we read. object X and Y on the server. We read those, and then we look through every ship on the client's game, and if that client's object ID variable is the same as the object ID that we received from the server, then O is now the ship that has that. Otherwise, then there was no ship that represents that object, and we need to create one to represent that guy. So we create him at the received X and Y, and then we set its object ID to equal the ID that we received from the server, so that it doesn't not find it again. So it actually does find it. We set its X and Y to the average of its current X and Y and the server's X and Y. So it basically makes it so they don't instantly teleport insane distances if you're really far away, and instead they kind of take a few frames to get all the way over there by constantly averaging. So it can technically never be exactly at the server position, but I will do that right now, I guess. If point distance. This will just make it so that it does eventually get directly on top. So if they're less than a pixel away from where they are on the server, I'll just teleport them directly onto it instead of averaging them. Because if I average them, you can always average two numbers regardless of how close they are together. So they would literally never ever be in the same position except for where they were when they were first spawned. Then we just read image angle, speed, direction, sprite index, and control. We just read all the stuff directly into the object's variables. And that's literally all the code in the game that I've showed you. One more thing to show you is that the server and the client are persistent, so even if you change rooms, the object is not destroyed and it doesn't lose any information. It keeps it, even if you change rooms or restart the room. That way, if you go from the lobby where you will join up and you go in-game, you're still connected. It doesn't lose that. Now, one thing I didn't show is the destruction of sockets and stuff, and that's very important because if you do go to the main menu and you want it to like disconnect you, it would not actually let you reconnect right now. It would never actually let you reconnect until you close the game by removing the process. So in the server, we set we do network destroy server. Or no, network destroy. Yeah, it doesn't have to be a specific server. And then we set server to an undefined value, so we can't reference it anymore. That way we know for sure that server is not anything anymore. And I will actually set server, well, I could set it to -1, that way it don't crash, because it's actually still a number. Yeah, that helps. Okay. We also need to delete all of these data lists to, you know, not take up an insanely large amount of memory. I only pasted that there for reference. So ds list destroy client ID. And I can copy that 3 more times. Whoops. ID, IP, port, and object. Alright. And that's not all. Now we set them to either undefined or -1. I'm actually going to set them all to -1. This way they cannot be referenced again, because if they're still set to whatever list they were before and you create new lists, these could still theoretically work, which is a problem. So you always, whenever you delete lists and stuff, make sure you set whatever value is holding that the list's ID or whatever to -1 or undefined. Either works. I like -1 because undefined can throw errors, while -1 would just work incorrectly. So in this case, we need to destroy this socket, and I think that's it. So network destroy socket. And that should be it. Now you've seen all the code in this game entirely, and I've explained every single line of every function and exactly how it all works. So let me go through one more playthrough, and I hit backspace to start the server. You see no difference graphically, and I hit C to connect. And you see a ship has spawned because a client connected, and I'm on the server and I am the host. So the server is not sending data to me because I'm the host. And if Ryan were to join, he would begin receiving sync updates every now and then, and he would be sending his input to me, and I would be processing them and moving a ship on my screen based on his keyboard. So that's how multiplayer games work in GameMaker, and that's how I've done this. This took me about, I think, maybe an hour or so to get to about this point, and then another hour of just messing around and occasionally touching on it. And there was a lot of waiting for Dropbox to sync so he could actually get the same executable as me. Yeah, though that takes a long time with this slow internet. But hope you guys enjoyed. If you did, leave a like. Hope you learned something. Subscribe for more, and I'll see you in the next video. Goodbye.